At the 2022 APS March meeting, the physics community gathers in Chicago and online to discuss new developments and research in physics. The hybrid March meeting program explores a wide range of topics, from nanotechnologies to quantum computers, gravitational waves, and much more. And APS TV is right here, bringing you all the latest from the meeting. Welcome back to the McCormick Place Convention Center and episode 2 of APS TV 2022. As attendees are joining the second day of the March meeting in person or virtually, we hear more from some of our APS thought leaders. We're joined by Donnell Walton, who is leading the Dr. Willie Hobbs Moore session, celebrating 50 years of African-American women PhDs in physics. We also speak to Nadia Mason, APS chair of the Committee of Scientific Meetings, and Nikta Fakhri, the 2022 Early Career Award recipient for soft matter research. We hear more about some of the universities leading the way in research and education. And finally, we ask you, the attendees, what you think the hottest topics in physics are right now. A lot of interesting content coming up there, so stay tuned and join us for our first interviews. You're watching APS TV. Donnell Walton is here with me now, and most people know what a pioneer Dr. Willie Hobbs Moore was, and you knew her personally. So, first African-American woman PhD in physics, paving the way for a lot of other African-American women, certainly. But on a personal level, tell us something we don't know.
So I went to University of Michigan, where she went to school a few years before me. And I was completely unaware that she had been there, nor any other African Americans. I was the only one in the program at the time, the PhD program at the time. And I met with Ron Mickens. He came to visit and he gave a talk on science. He's a physicist from Clark Atlanta University. And at dinner that evening, he talked about some of the pioneering aspects the University of Michigan had. He said the second black PhD in physics came from the University of Michigan in 1918, and the first black woman was Willie Hobbs Moore in 1972. He said, moreover, he believes she still lives in the community. So I made it my personal quest to find out where she was. I volunteered at a Saturday program for African-American students in science and math. And one of the person that ran it was Bill Ratcliffe, who is the father of APS fellow William Ratcliffe. I went to him that Saturday and I said, hey, do you know Willie Hobbs Moore? And he said, that's her right over there. You know, she had been tutoring with me every Saturday. I just had no idea. So I ran over to her and I introduced myself and said something, and she just kind of put her hand up in my face, didn't even look up, and said, I'm busy right now. And I was like, oh, wow. And then later that day when we were leaving, she came over to me, she said, sorry, I was at the verge of teaching this young lady how to prove congruent triangles or something. How may I help you? And I introduced myself again, and we started meeting every Saturday. Around that same time, I was asked to lead a black student organization meeting, the National Conference of Black Physics Students, which would have been held in DC that year. And I asked her, would she come? And she said, yes, she was happy to come. And we were going to give her the first Edward Boucher in honor of her pioneering work. We met, we talked, and then she kind of disappeared, and I couldn't get in touch with her. And I found out that she had passed. She had been living with cancer for over a decade. But in spite of that, she still, as I said, she was always mentoring, always working in the community.
The road that she paved, did she have any idea what a leadership role she had, what a pioneer she truly was?
I'm not sure how much she thought about it, but some people write about history, some people make it. She was definitely in the latter category.
Right. 50 years later, how far have we come?
We've come a long way, but there's still a long way to go. There are some biases, but I don't necessarily think it's bias against. I think it may be biases for. People tend to hoard opportunities. And we need to think about that aspect of it, right? As opposed to thinking that it's against someone, it's more for someone else.
And so what do you think people should be doing right now? How can we give people marching orders to make things better?
I think public good. I mean, thinking about education as a public good, healthcare is a public good. We've moved away from that. We've privatized many things. From my background, my socioeconomic background, today, the likelihood that I would have gone to school is much, much lower now because Pell Grants are minuscule compared to the cost of education. Grants and scholarships are how I went to school. I didn't have any parental contribution. And that has just gotten worse.
And I think educating people that it is an issue and it needs people to get involved, I think is one step toward making things happen.
I think that, public good is really the way I would address it.
No easy answer, certainly, but a very important topic to talk about. Thank you.
Thank you.
Now let's take a look at some of the latest work of U.S. universities in physics research and teaching. First, we're visiting Wake Forest University in North Carolina, where students benefit from a resource-rich environment and the opportunity to work on world-class research.
I'm Hardik Pandey. I am a third-year grad student with the physics department at Wake Forest University.
I'm a fourth-year graduate student in the physics department.
I'm a second-year physics graduate student at Wake Forest University.
My name is Lada, and I'm the second-year graduate student.
I'm the third-year physics grad student at Wake Forest University.
In our physics program at Wake Forest, we focus on 3 exciting areas.
We have astrophysics and gravitational physics, biophysics, and condensed matter material physics.
We're committed to high quality research and discovery, and we invite others to join us in this endeavor at Wake Forest University.
Come check us out, and we are sure you will like what you see. Become a member of the Wake Forest family.
The Department of Physics at Washington State University has a diverse set of ideas, from cold atom experiments and organic machines to quantum research and astrophysics. WSU is a wonderful community where you know your professors and your professors know you. Let's take a closer look.
Everybody here is really passionate about physics and astronomy. There's no dead weight here. I mean, look at every faculty member up and down the line, and you'll find somebody who is actively doing interesting research.
We do a bunch of research into something generally quantum dynamics.
My research involves discovery and creation of organic devices.
I am an observational astrophysicist, so I search for and study massive black holes at the centers of small galaxies.
It's a wonderfully supportive and encouraging environment where you'll get more understanding of fundamental physical concepts, but also great hands-on skills-based training for developing your research skills.
Coming to Pullman is a great idea. This place is just so beautiful, so nurturing, so encouraging. All the resources you could possibly need, you will find and get at Washington State University.
Duke University Physics offers all students unique opportunities for networking and interdisciplinary research, working side by side with the world's best scholars in an environment that enables groundbreaking research. Duke is the ideal place for students to begin their careers as scientists.
One of the big strengths of Duke University as a whole is that it is very encouraging of interdisciplinary research across departments and across schools. We have been traditionally very strong in nuclear and particle physics, and we have recently embarked on 2 exciting new initiatives. One is in cosmology, and the other one is in quantum computing, which is a joint endeavor with Duke's Electrical and Computer Engineering department, which I believe has led us to hire a world-class group of faculty. Being a member of our community in the department is very exciting. We have a stimulating research environment. The university clearly is investing a lot of resources into the sciences. So it's the whole package. It's the institution, it's the small administrative overhead that we have on our researchers, and it's the greater environment that makes this a very attractive place for people to come.
The goal of the Lehigh University Quantum Computing and Optimization Lab is to promote advances in the area of quantum computing and optimization. QCOL's research focus is on developing novel quantum computing methodologies and solving hard optimization problems to accelerate new scientific discovery.
The Quantum Computing Optimization Lab, as we abbreviate QCOL, is a group of professors and students, and have a good group of PhD students who are doing research in quantum computing optimization.
The QCOL Research Group is a group of interdisciplinary researchers, both within ISE and CSE. We also have members that are in industry and in national labs, and we seek to make Lehigh University an expert in quantum computing.
The main idea of quantum computing is to take advantage of a property of subatomic particles to make computations faster.
Quantum computing has the promise to solve problems which are unsolvable today. And if we can solve those problems better, faster, more efficiently, or solve those which are unsolvable today, that makes a huge impact for society.
I'm happy to be joined by Nadia Mason, APS Chair of the Committee for Scientific Meetings. Thank you so much for being here.
Yes, my pleasure.
I know it was a happy task, but it was a huge task putting this together. Talk to me about the areas of focus for the committee and really why you chose those areas.
Yes, absolutely. Well, first of all, I want to say it wasn't just our committee. I mean, putting this meeting together is a huge endeavor that takes the Division of Condensed Matter Physics, who runs the thing, and then all the way down the leadership, the American Physical Society thinks about this and helps organize it. So we're just sort of the last barrier to go through and think of policies and things to do at this meeting. But this year it was safety first. The process was, how could we maintain the standards of the meeting, of interactions, of people meeting with each other while being safe. Everyone wanted it to be in person. We did surveys and had people write in, and everyone wanted in-person meetings for sure, because you just can't replace in-person interactions at the March meeting.
You can feel the energy in the hallways here, in the sessions.
Yeah,
it's wonderful.
Yeah, absolutely. Just bumping into each other, hearing about talks and talking to speakers afterwards, one-on-one. Those are things, going out for reunion dinners. This is what makes it so special for all of us. So we all wanted in person, but we wanted it to be safe. And I should mention, it's an international meeting. So even though local standards have changed on mask wearing, people are coming from all over the world, and we wanted to make sure that everyone felt safe no matter where they came from and when everyone gets together.
And you worked very hard on that safety. I mean, just in terms of checking in and mask wearing while you're here.
Yeah, absolutely. And I think it worked. People here are filling out daily surveys, everyone has a vaccination check, everyone has a test before they come. And so I think I can definitely feel that people feel comfortable, which is important, and are interacting, right? Are doing what we want them to do.
In addition to safety, I know there were other considerations that were equally important for this meeting.
Yeah, one of the things we discuss a lot is how to make a more inclusive meeting. So we think a lot about a code of conduct, making sure that all members are treated respectfully and professionally. And we also thought hard about even where to hold the meetings. In the wake of the George Floyd killings, do we consider police interactions within the city where we're holding it? These are things that people may not realize, but we really care about having a welcoming, inclusive meeting where everyone can just think about science. Then that requires us to think about other things happening in the world. So it's really important, I think.
And it enhances their experience once they get here.
Absolutely, right? Because everyone has to be respected in order to be able to just focus on their work. And I think that's one of the things that underlies a lot of science is professional interactions, communications, collaborations in the most professional and respectful way possible. And we want to make sure that we can enforce that to the extent that we can.
And you are involved in a very special session for Dr. Willie Hobbs Moore. I want you to talk to me about that. The first African-American woman PhD in physics. That is pretty phenomenal.
It's amazing, right? 50 years ago, I can say personally that people like Willie Hobbs Moore, people like Edward Boucher, but really just paved the way for me. For me personally, I would say people like me, but me. I think that if she hadn't been able to go through at a time where there were very few African Americans in physics and no women, and get her PhD, have a research career, and actually continue to mentor people at Michigan, even when she was working in industry, I think it's incredibly important. And so I really appreciate that we're able to honor her today.
When you look around at the faces who are here, you must feel that inspiration from her, from you even now, that things have changed a lot.
Yes and no. Things have changed a lot, and yet they've changed too slowly for many of us. There's still a vast number of people who are underrepresented in physics, and so we have a long way to go. The APS is leading the way in terms of diversity initiatives, bridge programs, trying to bring more people in, but it's something that I think we all really need to work at still and push for.
And what do you think needs to be done? What's the most important thing to help people and to bring even more diversity? If they're leading the charge, how do you make it even better?
Two things, I would say. One is increasing pipelines, so making sure that the education system is robust, starting from elementary, middle, and high school through college, that it's inclusive to everyone. Everyone has opportunities. It's so varied in this country, what education, when people take physics, what their background is, whether they have access to research opportunities, that we really need to make that more equal across the board. And the other is just making sure the climate is welcoming and inclusive, and that's something that all of us can do individually.
Dr. Mason, congratulations on helping plan a great meeting, and thank you for joining us today.
Thank you.
We're APS TV, your daily news show featuring interviews and discussions on hot topics in physics from this year's APS March meeting. You can catch us around the convention center, in your hotel room, on the virtual meeting platform, and on YouTube. And you can join the conversation on social media. With new content each day of the meeting, make sure to keep watching. Let's take a look at education and research initiatives from universities around the world. Firstly, we'll travel to China, where Yangzhou University's Center for Gravitational and Cosmology was founded in 2017 to study the nature of gravity. The focus is on three different aspects of gravity research: black holes and gravitational wave physics, cosmology, and precision measurement experiments.
The Center for Gravitational Cosmology at Yangzhou University was founded in 2017, and we strive to tackle the most fundamental and frontier in the study of gravitation and cosmology. To push forward the research and also to increase the standing in the field, we have collaborated with international collaborators and domestic collaborators. Now our center has three main directions, including 21 centimeter cosmology, space gravitational wave detection, and also analog gravity. Collecting different data from astronomical observations can help us to understand better on the nature of gravity and cosmology. And we hope that more talents will join us to work together to tackle the most frontier and the fundamental problems.
At Carnegie Mellon's McWilliams Center for Cosmology, big data, simulation modeling, and AI converge to answer novel questions in cosmology and astrophysics. Let's see how they're using these research methods to study black holes.
The mission at the Mercurial Center is to really investigate, to go after these big problems in astrophysics. We ask these sort of fundamental questions about the universe. Every decade in the last 50 years has been defined by an increasing realization that black holes are absolutely fundamental part of our universe.
Black holes are responsible for a significant amount of the evolution of the galaxies and stars and star clusters that we see. Using cosmological simulations, people like Professor DiMatteo are looking at the mergers of some of the largest black holes in the universe.
The center is very supportive of its fellows and faculty members and students. Different areas of astrophysics and even fundamental physics might be of interest, and certainly something to look forward to in the future, especially given that interdisciplinary efforts at the intersection of these different fields is going to be helpful in answering fundamental questions about the physics and history of the universe.
The Research Institute for Applied Mechanics at Kyushu University, Japan, has been promoting international and domestic collaborative activities as an inter-university joint research institute to solve current social issues in the fields of the nuclear fusion, plasma physics, renewable energy, and Earth environment.
In 1951, the Research Institute for Applied Mechanics, RIAM, was established. RIAM's research focuses on mechanics and its application to solve important problems in today's society.
In the Renewable Energy Research Group, wind lens technology has been invented and developed, which is more efficient and environmentally friendly compared to traditional wind turbines. Plasma is one of the 4 fundamental states of matter. A significant portion of it contains charged particles, that is, electrons and ions. Welcome to a world of steady-state operation of tokamaks. Quest is the only tokamak in the world to be equipped with a plasma-facing wall capable of temperature regulation to control fuel particle balance, which we call a hot wall. The Quest project is promoted by many of domestic and international collaborators. We welcome you to join in our endeavors.
The research platform Turris at the University of Vienna is seeking to establish a joint effort of new approaches that address the big question of interfacing quantum physics with gravity. Let's find out more.
In nature, all interactions can be explained by either general relativity or quantum theory. Both theories have been tested independently and with extremely high precision. But it's still unclear yet if these theories interact, how they interact, and if a unification of both theories is possible. The research platform for testing the quantum and gravity interface, in short TURIS, at the University of Vienna, aims to address this question by putting together different research groups with complementary know-how to perform experiments in the laboratory to expose quantum systems to gravity.
It's very exciting because it's different cultures, although we're all physicists. Sometimes we benefit, and hopefully they benefit, to see things in slightly different ways. Not only the experiment, but the science.
Nikta Fakhri is here right now with me, the Early Career Award recipient for Soft Matter Research. First, let me congratulate you for the award.
Thank you so much, and thank you for having me.
Tell us a little bit more about your work.
Yep, so like many biophysicists, we are fascinated by the fact that there is something different about being alive, and we would like to know what that is, in the same way that we know what it means for a collection of atoms to be solid and for a collection of electrons to be superconducting. And to discover these laws, we do not always keep track of all the electrons and protons. We are always looking for important variables and key degrees of freedom. And once we know what these key variables are, we combine them into what is called an order parameter, which is the quantification of the emergent phenomena. And of course, this approach has been very powerful in physics of equilibrium systems, the physics of all the materials that are around us. However, life, by definition, is out of equilibrium. There is this famous saying that if you are at equilibrium, you're dead. So the question is, can we come up with principles that we can use to describe physics of non-equilibrium systems, such as physics of life? And this is a challenge that my group have set out to address. And to do so, we're experimentalists, so we develop experimental tools to observe non-equilibrium living systems. And then we come up with basically data analysis frameworks to define this order parameter fields. And then we, of course, collaborate with my theory colleagues to develop theoretical frameworks that have a predictive power. So this is, in a nutshell, what
in a nutshell, very deep research. Where do you see the research being applied, either for other research projects or even in everyday life?
I think it's a very exciting area of research. It actually falls under the umbrella of a very exciting research field called active matter, which is basically the idea that these active matter systems are many interacting parts that are that individually consuming energy and collectively generating motion and stress. And of course, it can describe physics of many systems, such as a flock of birds, all the way to a single cell.
How long have you been doing this research, and how does it feel for you to be recognized for it? Because you spend such a great deal of time on really complicated topics.
So I started kind of moving in this direction when as a postdoc. And of course, when I started my group at MIT, we really tried to delve into this question. And of course, I'm truly honored to be recognized by this award. It's obviously not just me, it's a wonderful group of students that I have at MIT, but also colleagues and collaborators all around the globe.
Well, it's you who's being recognized today, and we say congratulations.
Thank you.
Thank you for being here.
Thanks.
And finally today, we're speaking to you, the delegates, about what the hottest topics in physics are at the moment.
There are a lot actually, like the 2D materials, they are really, really hot right nowadays. And also there are many superconductivity, quantum computing, and yeah, there are many more perovskites. Yeah, we have a lot of topics on that.
It's hard to say. I think I'm pretty focused on my work, which is like optical spin defects, the applications for sensing and computing, and maybe like branching that out into biomedical stuff. It's kind of a little bit hard to get your blinders off, but like it's a great conference for just seeing like the breadth of stuff that's being studied.
My interests lie in biological physics and specifically ecological dynamics. And so one of the most important questions is to understand the ecological diversity of species that we see in the world using first principle models from physics.
Well, certainly quantum information is the big reason I'm here. So the revolutionary stuff that's happening in quantum communication sciences in terms of generation of non-classical photon states are really exciting, and there's some incredible results here at the APS March meeting.
That's it for our second day here at the 2022 APS March meeting. And it's been a very busy day here in Chicago and on the virtual meeting platform with sessions and talks on a wide range of issues. Tomorrow, we'll hear more about the latest on APS journals, and we'll take a look at some of the companies driving innovation in quantum research and development. Before then, you can watch the show here at the Conference Center, in your hotel room, and online. And don't forget to subscribe to APS TV on social media. We'll see you tomorrow.